Hi everyone, and welcome back to Maths and Physics with Mr. Simons. Today is grade 12 analytical geometry lesson, the second one here in analytical. Going to be testing whether you can substitute coordinates that has an unknown into equation of a circle and find that points. Alright, relatively basic. So 4 and a, my x value is 4, y is a is a point in the circle, x squared plus y squared equal 20. Determine all possible values of a. So in the place of x squared, substitute 4. Place of y squared, I'm going to substitute a equal 20. 4 times 4 gives me 16. 8 times a squared. If I take 16 over, this becomes 20 minus the 16, which can give me 4. To go from a squared to 4, I'm going to find square root. But square root of y, and if I say square root of 4, I must say plus minus. Square root 4, which then becomes a plus minus 2. So that's why they said possible values of a. Once you have that, we can say determine the distance between the 2 points. So now technically you have 4 and 2 and 4 and negative 2. Right, that's where the plus and minus 2 comes in. So distance formula, square root x2 minus x1 squared plus y squared minus y1 squared. So we start off here, 4 minus the 4 squared and 2 minus minus 2 all squared. 4 minus 4 gives me 0. 2 plus 2 gives me 4, so 4 squared would give me 16. Square root 16 then gives me 4 units. So the distance between these 2 points equal 4 units. Right, let's look at the next problem. Alright, example 2.2. 2 points A and 6 lie on the circle x squared plus y squared equal 85. Now instead of asking you separately, we can say determine the distance between the 2 points. Before I can get the distance between the 2 points, I need to get the values of A. So in the place of x squared, I put a squared. In the place of y squared, I put 6. 85, so 8 times a squared, 6 times 6 gives me 36. If I take 36 across, 85 minus the 36 gives me 49. To go from a squared to a, I'm going to say square root of a squared gives me a. Square root of 49 becomes plus minus 7. So my 2 points is 7 and 6 and minus 7 and 6. So for distance formula, square root x2 minus x1 squared plus y2 minus y1 squared becomes 7 minus minus 7, right? Square, don't get caught out with this minus minus. So whenever we mark this, you'll go write 7 minus 7, not realizing the other point is already negative. So that's why it becomes 7 minus minus 7. That one simply 6 minus 6, which becomes 0. So 7 plus 7 gives me 14, and 14 squared gives me 196, which then simply becomes square root of that, 14 units. Right? So that is typical question if we ask, can you get the distance between 2 points given one unknown? Hope you're still with me. If you're enjoying the lesson so far, please like and subscribe. Alright, now number 3. A3 and minus 4 is a point in a circle with center at the origin. Determine the equation of the circle. So center at the origin, so I'm working with x squared plus y squared equal r squared. Right, to get the values of r, x becomes 3 squared and b becomes minus 4 squared. So 9 plus 16 then gives me 25. So x squared plus y squared equal 25. Now determine the coordinates of B if AB is a diameter. So A is 3 and minus 4, and B would be minus 3 and 4. Basically for it to be a diameter. The points are reflected. Right? So reflection across x-axis, 3 and minus 4 becomes 3 and 4. and reflection across the y-axis, or reflection across x-axis. I'm going this way across. So you see my values there. My x value stays the same, it's basically 3, and my y value goes from -4 to +4 if I reflect across the x-axis, and reflection across the y-axis, if I go from there to there, -4 then becomes +4, and positive x becomes -x. So I can get the coordinates of B if AB is the diameter. So if A is 3 and -4, B becomes -3 and +4 due to those two reflections, right? Then show that the point C, 0 and 5 lies on the circle. So according to this, x is 0 and y is 5. So if I substitute 0 into the equation, I must get y as 5. So x squared becomes 0 squared plus y squared equal 25. From there, square root of y squared becomes y, and square root of 25 comes plus minus 5. Therefore, C, 0 and 5 must lie on the circle. Right? We're just substituting one to get the other one. Now prove ACB is 90 degrees. So we had A as 3 and -4. We had B that we found as -3 and 4. And we had C equals 0 and 5. So if I work out the gradient of AC, it's y2 minus y1 over x2 minus x1. So for AC, start there, -4 minus 5. 3 minus 0. So that gives me -9 divided by 3, which then gives me -3. If we do gradient of BC, so I'm working with B and C, I'm going to say 4 minus 5 minus 3 minus 0. So those are points I substitute in. 4 minus 5 gives me -1. Minus 3 minus 0 gives me -3. Negative divided by negative becomes positive. So gradient BC is 1 over 3. So gradient of AC times the gradient of BC minus 3 times positive 1 over 3 should give me -1. So that gives me -1. That means AC is perpendicular to BC. So AC is perpendicular to BC, meaning where they meet, there must be a 90-degree angle. Therefore, ACB equal 90 degrees. Right, I hope everything I've done so far makes sense to you. So in exam, we'll either ask you to test if something is perpendicular or parallel via the gradients. It's just a quick revision of grade 11 work that can be tested with the grade 12 work. Please like and subscribe. God bless. Bye.